So today we're going to take a look at this vector investigation. And when you click on this link, you might want to make sure you open it in Chrome or Safari. I couldn't get it to work in Firefox. So hopefully you can bring that up. And then the first thing it says for us to do is to click on the instructions button. So let's see. So instructions. Let's see here. Static, steer the boat to an island. Dynamic, direct the boat to intercept moving school of fish. And then you can combine it as well to earn points for your destination. So what we're going to do today is, let's see, what else does it say? The magnitude and direction, the boat's speed, is always active. It can be adjusted by dragging either end of the vector to different numbers in the boxes. And then it says the water can be toggled on and off. The resultant arrow can be toggled on and off. Start, reset, and new game. So if we go back to this activity here, the first question it asks us, so let's see, it says try moving the instructions button and read the instructions. Oops, try moving the blue vector by dragging the end of the vector and changing the number beneath the blue vector. Can you hit the island? So let's go back here. So let's see. So if we move this, yeah. Oh, did I really get it in the first shot? Nice. Let's see if I reset it. We can do a new game, move it around. Let's see. Well, that was too far, so maybe we reset that. So mess around with this a little bit, and one thing I notice as when I change this, the magnitude and the direction change. So if I go back here, and let's see, so I hit the island, so magnitude changes, which to me looked like it was the speed, and the direction changed. So the next thing here, let's scroll this down here so we can see what we need to do. In static mode, turn off the red vector. Turn on the resultant green and direct the boat. How does the length of the magnitude affect the boat? So if we go back here, turn off the water, turn on the resultant, start. Let me reset this game. So water, we don't want anything. And if we start that, 1 and 13. Well, the direction is still the same, it looks like. Let's see if I do a new game and start this. Start. Well, now the magnitude and direction are exactly the same. New game. And if we start, what happens if let's reset this. What happens if I change this a little bit? Oh, well, now it looks like the magnitude and the direction are exactly the same. So if we go back here, how does it affect the magnitude, affect the boat? Well, that looked like that was the speed. And what did you notice about them? That they were the same. So the next thing you need to do is direct the boat to the island and just one shot with the water turned on. So if we go back to our game here, turn on the water. Hey, nice. Let me try a new game. See if I can get this here. Let's see. Okay, how about here? And I landed it again. Good at this game. All right. So let's see. What is it asking us to do here? So the next thing it says, complete the exploration. Set the magnitude to 10 and the boat direction to 10. Okay. So magnitude, reset. Or 10, what was it, the other one? I think it was 150. Okay. 10 and 150. All right. So what does it say to do? Whoops, that's not what I meant to do. This one. And bring up this again. Okay. Draw a picture of the vector. Notice where 0 is. So 90, 180. So it said 150. Draw a leg in, the circle part of your vector should be at the origin. So here would be angle 150, because 0 a little bit more than 90, and that could be, I could try drawing this a little bit more accurately, and I'll actually get a vector here. So, alright, so there's that vector, 150. Draw a triangle to the 0 and 180 line, so I can draw this on down. Label your hypotenuse as 10. Label your reference angle, so this would be 30. And then let's see, it says find the other two lengths of your triangle. So if we labeled this x and y, we could set this up to find these. So opposite over hypotenuse. So the sine of 30 equals x over 10. And let's see, what would this one be? Adjacent. Cosine of 30 equals y over 10. So if we multiply by 10, we got 10 times the sine of 30 equals x. 10 times the cosine of 30 equals y. And let's see, we need a calculator here. So let's go to Desmos. And let's see, first thing I better make sure to change this into degrees. So let's see, 10 sine of 30, 10 cosine of 30. So we have 5 and 8.66. So x equals 5, y equals 8.66. Fill in the blanks below. So x part was 5, comma 8.66 was our y. Okay, well the next part here, set the water magnitude to 8 and boat direction to 130. 8, 130. Okay. Done. And then we'll draw on the same thing here. So 130. Let's see if we draw that in. Well, if that's 130, this is 50 degrees. So it's kind of turned on its side here. And let's see, what should our hypotenuse be? 8, x, and y. So we can set up those trig functions again. The sine of 50 equals x over 8. Cosine of 50 equals y over 8 times 8 times 8 times 8 all around. So 8 times the sine of 50 equals x. 8 times the cosine of 50 equals y. We'll jump back here to Desmos. Let's see, so 8 sine of 50 and 8 cos of 50. So we have 6.12 and 5.14. 6.12, 5.14. So it says x and y again. And now it says you take your components and add them together. So let's see, what did we have? So our boat was 5, 8.66, 6.12, 5.14. So if we add them together, 11.12 and 13.8. And it said, let's take a look at our boat. What was our resultant? 17.7 and 141.13. So draw a vector in with these x and y components. So our x and our y. So it would be down here, and we could draw it in anyway. I'm going to draw in that arrow again because it looks like our resultant was right there. Let me see, let's try that again. Alright, so if we did our x of 11.12 and 13.8, well, what theorem could we do? The Pythagorean. 11.12 squared, 13.8 squared. That equals c squared. So jump back to Desmos. 11.12 squared plus 13.78 squared. And if we take the square, so square root of 313.5428, we end up with 17.7. And if we look at that, that is the exact same as our length of our vector. And let's check that angle there. So we said 17.7. And how do we figure out this angle here? Well, we could do all sorts of trig functions. If we did the tan inverse of opposite over adjacent, jump back here. Let's see, functions 11.12 divided by 13.8, so 39 degrees. So if this is 39 degrees, what's our actual angle? Well, 180 minus 39, that's about 141. And if we take a look here, that's what we have for our resultant vector. So when we look at this, what we're really doing is we're finding what's called the components of our vectors and adding them together. Now onto this back page here. It says set the magnitude and direction for the boat, so the boat and water, so the boat remains stationary. Okay, so let's go back here. We don't want it to move. Well, I'm guessing. Wonder if we just oh, it's still moving. Wonder if I did this as, because I'm thinking they need to be opposite each other. If we had 180 and does it not let me do 360? So what if we did 179? So it's still moving. Wonder what if we switched our directions here, or our magnitudes. What if we had that be like 10 and 10? So now they're not moving at all. So the boat, they're facing opposite and the same length. So if we went back here, they're opposite and the same length. So then what you have to do is answer these questions. How do the numbers for direction and magnitude correspond to the vector appearance? Well, that's obvious, our direction, and this one is our speed. The movement, that again was our magnitude. And then you guys go ahead and try answering the rest of these questions.